I'm always amazed at how data shapes our understanding of the world around us. Hi, I'm Mayank Agarwal, and welcome to the Quality Excellence channel. Today we're diving into the fascinating world of continuous data. You might think, data? Fascinating? But trust me, by the end of this video, you'll see how continuous data is the secret sauce in the recipe of quality improvement and informed decision-making. What exactly is continuous data? Well, it's like the smooth jazz of the data world. It can take on any value within a given range. Think of it as the measuring tape of information. You're not just counting discrete items, you're measuring a continuous flow of values. Weight, temperature, time, length, speed, these are all examples of continuous data. Let's break it down with an example. Imagine you're measuring the height of people in a room. You wouldn't just say tall or short, right? You'd get specific. 5 feet 8 inches, 6 feet 2.5 inches. That's continuous data in action. It's precise, it's measurable, and it can be divided into infinitely small increments. Now, you might be wondering, how is this different from discrete data? Great question. Let's have a little showdown. In one corner, we have continuous data, the smooth operator that can take any value within a range. In the other corner, discrete data, the count by numbers type. A quick way to tell them apart: if you're measuring something like 5.1 kilograms or 5.15 kilograms, you're dealing with continuous data. But if you're counting something like 5 apples or 6 defects, that's discrete data. Continuous data is like a river flowing smoothly, while discrete data is like stepping stones across that river. All right, we've got this continuous data, but how do we make sense of it visually? This is where things get really cool. We've got a whole toolkit of visual representations, histograms, line charts, and scatter plots. These aren't just pretty pictures. They're powerful tools for understanding our data. Let's focus on histograms for a moment. Imagine you're measuring the length of bolts in a factory. A histogram would show you the distribution of these lengths, like a mountain range of data. You might see a nice symmetrical bell curve if your process is consistent, or you might spot some outliers that need investigating. It's like giving your data a visual voice. Histograms are just the beginning. We've got a whole Swiss Army knife of analytical tools. Box plots, for instance, are great for spotting outliers and understanding the spread of your data. And then there are control charts, the superheroes of process monitoring, X-bar and R charts, X-bar and S charts. These are like the vital signs monitors for your processes. And let's not forget about our good friends, descriptive statistics, mean, median, mode, standard deviation. These might sound like boring math terms, but they're actually the secret agents of data analysis. They give us quick, powerful insights into what our data is telling us. It's like having a data detective squad at your fingertips. Now I know what you're thinking. Mayank, this all sounds great, but what about the actual math? Don't worry, I've got you covered. Let's talk formulas. For the mean, it's simple. Just add up all your values and divide by how many there are. In math speak, that's sex. N. Standard deviation is a bit trickier, but super important. It tells us about the spread of our data. The formula looks scary. Sigma equal sign, SXI, M2 is N. But it's just measuring how far each point is from the mean on average. And let's not forget the range. It's just the maximum value minus the minimum value. Simple, but powerful. These formulas aren't just abstract math, they're the building blocks of understanding our data. They help us see patterns, spot anomalies, and make informed decisions. It's like having X-ray vision for your data. Okay, now we're getting into the really good stuff. Process capability. This is where we figure out if our processes are actually doing what we want them to do. We use two main measures here, CP and CPK. CP is like the potential of your process. It tells you what your process could do under ideal conditions. The formula is USL, LSL are sixes, where USL and LSL are your upper and lower specification limits. But CPK, now that's where the rubber meets the road. It tells you how your process is actually performing, taking into account where your data is centered. The formula is a bit more complex. Min, USL, mu, are threes. Mu, LSL, are threes. Don't let these formulas scare you. They're your friends in the quest for quality excellence. Now that we've got all these tools and formulas, how do we make sure we're using them correctly? Enter the continuous data checklist. First, are you actually measuring a continuous variable, not just counting? Are you using the right tools like histograms or control charts? Are you calculating your summary statistics correctly? These might seem like simple questions, but they're crucial for valid analysis. How does this all come together in the real world? Let's walk through a typical timeline for continuous data analysis. Day 1, 2. Define your variable and collect data. Day 3. Plot your histogram and calculate those important statistics. Days 4, 5. Apply your control charts or regression analysis. Day 6. Interpret your results and summarize. Day 7. Present and document your findings. It's a journey from raw data to actionable insights. Why does all this matter? Because continuous data is the foundation of statistical control and improvement. It's not just numbers, it's the key to making informed, data-driven decisions that can revolutionize quality in any field. By understanding, visualizing, and analyzing continuous data correctly, we unlock the potential for real, measurable improvement. It's the difference between guessing and knowing, between hoping and achieving. And there you have it, folks. We've journeyed through the world of continuous data, from basic definitions to powerful analytical tools. Remember, every time you measure something precisely, you're working with continuous data. So go out there and start analyzing. Thanks for watching, and don't forget to like, share, and subscribe to the Quality Excellence channel for more insights. This is Mayank Agarwal, signing off and wishing you continuous improvement in all you do.